Welcome to tutorial 18, where we're going to be looking at the NAND Gate Bi-stable. We have previously done A-stables, monostables, and now we're looking at a bi-stable. I think it's worth probably just going back over exactly what we mean by those terms. Now, looking at the A-stable, if we remember, an A-stable was a continuously changing output waveform. It oscillated. In other words, it had no stable states because it changed and then changed down and up and down. A monostable, however, the output of a monostable is always low until we triggered it into action, and then the output went high, and the output stayed high for a certain amount of time, and then it went low again, where it would stay low forever until it was triggered again. In other words, this off state is the stable state, and this on state is the unstable state. So an A-stable has no stable states. A monostable has one stable and one unstable state, and so perhaps you should be able to guess that a bi-stable state has two stable states. In other words, we're going to trigger it into action and it will go high. Then we're going to trigger it into action again and it will go low. It will stay high forever unless we trigger it back down, and it will stay low forever unless we trigger it back up. So this has two stable states. So looking at our circuit in front of us, we have a number of little arrangements that perhaps we can just have a quick look at. First of all, we have two switch inputs. We're going to call them S and R. There's a reason for that. The S will represent set and the R will represent reset. You will also notice that there is a bar above the S and a bar above the R. This is quite important in this circuit because when we press the switch, the input to the NAND gate will go low, whether it's the S or whether it's the R. When we press the switch, the inputs go low. Looking at our NAND gate arrangement, you will also notice that the output of this NAND gate goes back to the input of this NAND gate, so it will affect the output of this NAND gate that goes back to the input of this NAND gate, and it will affect this NAND gate where the output goes back to the input. We have seen this before slightly. This is called feedback. We are feeding back the outputs to the inputs, which has an effect on the outputs that get fed back to the inputs. And then finally, we're going to call this output here Q, but we are going to look at this output a little bit later. And this output Q goes to the input of our inverting buffer. So when Q is low, the output is high and the LED is off. So when Q is low, the LED is off. When Q is high, the LED is on. Okay, let's have a little look at that circuit and see it working. The first thing to do, however, of course, is always to test our switch input circuits. So I'm going to test R. R is high. When I press the switch, if you remember, it goes low. And with S, when I press the switch, it goes low. Okay. So, having a quick look at our circuit, going to number our pins, pins 1, 2 and 3, 6, 5 and 4. Let's remind ourselves very quickly as well about a NAND gate truth table. So different possibilities are in a 2-input logic gate are 00011011, and the output of a NAND gate is this. In other words, this is the important one, because the only time we have a 0 at the output of a NAND gate is when both inputs are 1. So what sort of testing can we do on this? Well, I've written down a little table here for you to follow, but let's look at what this does first of all. Just going to put my switches back in. So S goes to pin 1 and 2, and R goes to pin 5. Can't go in the breadboard. There we go. So watch what happens. When I press R, the LED goes off. When I press S, the LED comes on. In other words, the output of our NAND gate, Q, is going high and low. When I press S, it was set. When I press R, it is reset, goes low. When I press set, it goes high, is set. When I press R, it's reset, goes low. Now this is a particularly useful circuit, especially in project work. It enables us to be able to turn something on and turn something off and latch it on and off. In other words, latch is when it will stay in that position until we do something else to alter it. So let's run through our little bit of testing. So first of all, state 1, when S is 0 and R is 1. So remember, to make S 0, I have to press the switch here. Because of this pull-up resistor, I press the switch. And what happens? Q goes high. Next state, where S is 1 and R is 1. So I'm going to release S, and Q remains as a 1. Next state, where R is 0. So to make R 0, I need to press R, and Q goes low. Now where they're both 1 and 1, and therefore Q remains low, and then back to our original state, back to state 1, and Q goes high. So looking at these, is the bistable set or reset? Well, if Q is a high, it is set. Set. If Q is 0, it is reset. Reset. And Q is high, it is set. When the switch S is pressed, the input S goes low and the output Q goes high. The bistable is now said to be set. If S is now taken high, the state of Q is high because it hasn't changed. In order for Q to go low, R must be taken low with S high. Now what happens when both switches are pressed at the same time? Well, let's do that. I'm going to press them both at the same time, and the LED is on, therefore Q must be high. I'm going to press S just slightly before R. Now I'm going to press R slightly before S. On all occasions, Q remains high. However, that may not be a true indication of what's happening in the circuit. Why is this undesirable? Well, quite clearly, if I am pressing the reset and Q is high, it is not being resetted. In other words, we can't have set and reset happening at the same time. What do you think is the relationship between Q and the output of the other NAND gate? Well, if we look at that circuit again, here is Q. What is the output of this NAND gate? Well, rather than build another output circuit, we know that the output there is pin 4, so I'm going to just connect up a logic probe. And that will show me the state of Q, or the other Q if we like. So I'm going to press set, which should bring this LED on. And look what happens. The other output goes low. So this Q is high, this Q is low. I'm going to press reset. As we know, Q is reset, goes low, and the other output goes high. In other words, they are opposites. In other words, the two outputs, one is Q and the other is not Q. So we could draw that onto our diagram, not Q. This is the end of tutorial 18.